Hi guys! Salamat sa inyong patuloy na ginagawang pagsubaybay dito sa ating discussions about mechanics of deformable bodies. In today's discussion, I will be presenting to you two problems about axial deformation. Okay, and now I hope that with these two problems, you shall be able to fully understand how to apply the concept in solving engineering problems. But before we continue, guys, I am inviting you to continue watching my uploads by subscribing to my channel and sharing this to your friends so that your friends will also be notified whenever I have new uploads. Guys, ito yung problem. Actually, this is already my second problem because my first was already given in the previous discussion that I have. The rigid bar AB, which is attached to two vertical rods, is horizontal before the load P, which is equal to 50 kN, is applied. Determine the position of P such that the bar AB will remain horizontal. And what is the vertical movement of the bar AB? So I have here in the figure, bar AB, which is supported by two vertical rods, aluminum and steel. The property of the rods are indicated such that the aluminum has a length of 3 meters, an area of 500 square millimeter, and a modulus of elasticity of 70 gigapascal, while that of the steel has an area as a length of 4 meters, an area of 300 square millimeter, and a modulus of elasticity equal to 200 gigapascal. At a certain point at a distance x from A, there is a 50 kilonewton load applied, and it is expected to determine what is that value of x so that this bar AB will remain horizontal. Aside from that, we are also required to determine how much is the vertical movement of AB. So let us try to animate and show what will happen to AB when this is applied with a load at a position that will cause it to have the same deformation. Let us try to show it. When P is applied, it will have the same deformation. It will remain horizontal. And that, let us try to indicate that this is our point A and B, and this will be our deformation that is caused by the applied load on the horizontal bar on the aluminum rod. Okay, and we call it as deformation of AL. Whereas on the right side, I have here the deformation of the steel caused by the pulling effect of the 50 kilonewton load applied at the horizontal bar. Now, if the bar is to remain horizontal, then the aluminum and steel bar must have the same deformation. Therefore, we can say that the elongation of the aluminum must be equal to the elongation of the steel. But we learned that the deformation has the following formula, that it is equal to PL over AE. So that if we were to substitute that formula, I will have here PL over AE of the aluminum shall be equal to PL over AE of the steel. And what is this P of the aluminum? It must be the internal force or the axial force that would be acting on the aluminum. Similarly, P of the steel must be the axial load acting on the steel. And how are we going to show it? So if we're going to isolate the bar AB from the rods, aluminum and steel, so that this will be the isolated bar of our AB, then this is the axial load acting on the aluminum, while this one is the axial load acting on the steel. So that if we are to substitute that in the formula as well as those given, those property of the aluminum and the steel, therefore our equation will become equal to P of the aluminum times 3 divided by 500 square millimeter, multiplied by 70 gigapascal shall be equal to P of the steel multiplied by 4 divided by 300 square millimeter, multiplied by 200 gigapascal. And from this equation, you will notice that the units of meter here will cancel, as well as square millimeter, and that of the GPA will also cancel. So that if this will be simplified, we can now get the relationship between the aluminum and the steel, so that the aluminum and the steel will be related. So in the form that the aluminum is equal to 0.7778 of that axial load in the steel. Now, after getting that, if you are going to apply the condition of equilibrium to the isolated part of the bar, therefore applying the condition of equilibrium that summation of force vertical shall be equal to 0. Therefore, our equation becomes the P of the steel plus the P of the aluminum shall be equal to 50 kilonewton. And if you are to substitute the P of the aluminum to be 0.778 P of the steel, therefore this becomes 0.7778 P of the steel plus P of the steel shall be equal to 50 kilonewton. So that 1.7778 P of the steel shall be 50 kilonewton, and from here we can solve the axial load on the steel to be 28.125 kilonewton. So if this will be multiplied by 0.7778, therefore we can solve for the axial load on the aluminum to be 21.875. So after we have computed for the value of the aluminum, so we can have, okay, take the value of the moment or the x by applying the other condition of the moment, that is equal to, okay, summing up moment about A equal to 0, so that, okay, you can have formula to be P of the steel multiplied by 6 minus 50 multiplied by x shall be equal to 0, and from here you can solve for the value of x to be 3.375 meters from A. And so after that we can now define for the total deformation, okay, of, okay, the bars, which is the movement, the vertical movement of the horizontal bar AB. So that we will have here, okay, to solve for the vertical movement of the horizontal bar, the deformation of aluminum being equal to the deformation of steel, using the formula that is equal to PL over AE, then our equation becomes 21,875 Newton multiplied by 3,000 millimeter divided by 500 square millimeter divided by 70 times 10 cube Newton per square millimeter, and that our deformation becomes equal to, okay, if Newton will cancel as well as square millimeter will cancel, the resulting unit will be 1.875 millimeter. So guys, that is our first problem, a simple application of the deformation in solving a problem. The next problem that I will be presenting to you is a somewhat more interesting one. This is a problem that I have taken from the book, and when I examine the solution, okay, there are a lot of solutions that is already available. However, if you will look at the solution, you will find it hard to follow the solution because you have, particularly kung hindi mo nakikita kung ano yung process, hindi mo siya agad basta-basta masusundan, ano? So, and here is the problem that I have, guys. The two aluminum rods AB and BC hinged to rigid supports are pinned together at point B to carry vertical loads of 6,000 pounds. I will be presenting to you the figure. So I have here AB and BC, that is to support vertical loads. These are, okay, rigidly supported at the wall and pinned together at point B, and it is to carry a load of 6,000 pounds. If each rod has a cross-sectional area of 0.6 inch square and a modulus of elasticity of 10 times 10 to the 6 psi, compute the elongation of each rod and the horizontal and vertical displacement of point P. So, kung pinapahanap sa atin dito, okay, yung horizontal, yung elongation or deformation of this AB and BC, considering that this will be supporting the load of, okay, 6,000 pounds. After that, we shall be looking at, okay, the vertical movement of this point B as well as the horizontal movement when this is subjected to a load of 6,000 pounds. So let us try to work on this problem by solving first for the axial loads acting on each of the members AB and BC. And we can solve for this by applying the method of joint. That is, if we're going to isolate joint B as FBD, then we shall be having this as our illustration. Let us try to take this B as our joint, and from here we show the forces acting. Unahin natin itong 6,000 pounds acting there. Okay, meron tayong 6,000. Then sundan natin itong BC that will be acting, assuming natin that this will be acting up to the left to support the vertical direction of the 6,000 pounds. And so I have here this direction. Okay, and let us call that as our BC. Similarly, we will be having a force coming from AB, and that direction may be assumed to be directed, okay, from B to A, as to balance the leftward direction of this BC. And let us imagine that this is our B taken from here, so we will have it as our AB. The angle that AB and BC makes with respect to one another is equal to the sum of these two angles, and this is equal to 60 degrees. And so from here, we're going to, okay, consider the force triangle method. Okay, we shall be forming this triangle representing the concurrent forces in equilibrium. Okay, and that is equal to, this side will be equal to 6,000 pounds, while this side is our AB, and this side will be our BC. The angle between AB and BC will be represented by this one, and that is equal to 60 degrees. Similarly, we can expect that this angle, okay, the angle that BC is making with respect to the horizontal will be this one, and that is also equal to 60 degrees. And so this is also equal to 60 degrees. If we are going to examine the resulting triangle is actually an equiangular triangle. And therefore, if this is an equiangular triangle, okay, the same triangle is an equilateral. And therefore, the sides shall be equal, and hence we expect that the side BC representing this force shall also be equal to 6,000 pounds, and which is subjected to compression, while the side AB is also equal to 6,000 pounds, and that is subjected to tension. Now, if BC is in compression and AC is in tension, therefore, we would expect that BC will be shortened and AB will be elongated. Now, let us now try to solve for the elongation or deformation caused by the axial loads upon the two members. Let's start with finding for the axial deformation on the member AB, where AB is subjected to tension. Okay, considering the formula that the deformation shall be equal to PL over AE, right? And if we're going to substitute the value, the deformation shall be equal to 6,000 pounds times 120 inches, equivalent to 10 feet. I simply have converted that into inches. Then I have here the area of 0.6 inch square and the modulus of elasticity of 10 times 10 to the 6 pounds per square inch. PSI is pounds per square inch. And you will notice that in this formula equation, pounds will cancel as well as inches square will cancel, and the resulting unit is a unit of an inch, and the value of which is equal to 0.12 inch, and that is an elongation. Now, if we're going to solve for the axial deformation of the member AB again, we are to use the formula that the deformation is equal to PL over AE, and that the value of the computed value of P is substituted, as well as the properties of the member AB. Therefore, the equation becomes equal to the deformation shall be equal to 6,000 pounds multiplied by 72 inches, representing the length of the member BC, which is 6 feet, divided by the area of 0.6 inch square and the modulus of elasticity of 10 times 10 to the 6 pounds per square inch. Again, in this equation, pounds will cancel and inch square will also cancel, and the resulting unit for the deformation of the member BC equals 0.072 inch, and that is shortening. Shortening because member BC is subjected to compression. Now, after getting those elongation, let us try to imagine ano ba yung mangyayari dun sa ating point B kapag in-applyan siya ng load na 6,000. Siguro mas makabubuti kung ipakita natin siya in this form. So, actually mangyayari kung ito muna yung kanyang original position ng member A and BC without the load, when this is loaded with 6,000, gumalaw ngayon siya, di ba? So, wala siyang load, nung nilagyan, gumalaw siya. Wala, gumalaw, wala, gumalaw. Di ba? So, ganyan yung mangyayari sa ating member, and we wanted to determine ano yung naging movement itong B before it is applied, and then what happens kung yung B ay narito na. Diba? So there will be now what we call the horizontal and vertical movement of point B, and that is what actually we are looking for. Now, para ma-visualize natin, kasi kung dito tayo titingin, kapag masyadong mabilis yung galaw, hindi natin siya makita mabuti. Siguro gawa natin ng paraan. Let us try to gawa natin ng slow motion, yung movement, at ipakita natin yung konsepto. Bakit ba ganun ang nangyari? Now let us try to go back here. Kunwari ito yung ating applied load at in-apply na ngayon siya ng 6,000 pounds. Then we already have computed the elongation of AB and the shortening of BC, di ba? Ngayon, halimbawa na inallow natin na yung member AB ay humaba at yung member BC ay umikli after the load, okay, is applied. And that would only happen kapag tinanggal natin itong pin. Subukan natin kaya tanggalin yung pin and then we allow the deformation to occur freely. Tanggalin ko yung pin, tinanggal ko yung pin and then we allow the deformation to occur freely. Ito na yung nangyari. Kaya mula sa B, humaba na itong AB, umikli naman itong BC. Di ba? So kung tinanggal natin at meron siyang paghabat pikli, hindi na natin may kukonekta yung dalawang ends. Di ba? Kaya ito tanong paano ba kaya sa palagay natin na gagawin natin para muli natin mapagdugso yung dalawang ends without anymore applying stresses on the material. So para mapagdugso natin itong dalawang end neto, kinakailangan itong member AB at BC, ma-rotate natin siya in the same direction until the two ends meet. Di ba? So paikutin natin siya, pipihitin natin siya in the same direction. Wala na siyang stress kasing dapat i-apply. Kasi na-subject na siya sa stress, kaya nga humaba. Ito naman, kaya nga umikli dahil na-subject sa stress. Ang gagawin na lamang natin dyan, pagduduksungin na lamang natin yung dalawang ends by rotating. And this is what will happen. Let us try to show it in this manner. Okay? Kapag pinihit natin siya ng papaganyan in the same manner, okay, in the same direction, until their ends both meet, then we can return back our pin. At yan yung magiging final position ng ating B. Di ba? So ulitin ko lang ulit, ipakita natin. So kung yan, humaba na itong AB, umikli na itong BC, kapag pinihit natin siya in that direction, okay, maibabalik natin yung pin. At yan ngayon yung tinatawag nating final position. Di ba? At ang hinahanap natin ngayon dito, ano yung vertical movement itong B papunta sa BF at ang horizontal movement ng B papunta sa BF. That's actually we're looking for. Most of the book have presented solution on this part. Kaya lamang kung mapapasin ninyo, kaya tingnan ninyo, balikan ninyo yung solution. Hindi nyo siya basta-basta agad masusundan. Unless naintindihan nyo na yun pala yung dapat na ginagawa para muling mapagdugsong yung dalawang ends ng dulo kung hindi na ngayon siya magkatapat. Di ba? Ngayon, makikita natin if we are to consider, okay, this member AB has been rotated by an amount equal to this angle. And because of this rotation, itong line na ito ay that's actually a curvature. But because this is very, very short, very, very small, as the deformation is very, very small compared to the length of 10 feet. Imagine mo yung deformation is 0.12 lang, 0.12 of an inch. Considering the total length of 120, napakaliit niya. Sa pagkatwid, itong arc length neto can be considered after the elongation to be a straight line in that direction. Similarly, mula dito sa end neto, nitong ating BC naman, nung umikli na siya by this amount, okay, itong line na ito, itong kurbada na ito, will be treated to be a straight line. Di ba? Why straight line? Because this deformation is very, very short kumpara sa length, the original length of the member. Kaya sa halip na kurbada ito, ang treatment dyan shall be a straight line. Kaya kung titignan natin, dito tayo magko-concentrate ngayon. At dyan natin makikita ngayon yung movement ng B from B to the final position BF. So let us try to consider this length or this angle, because we will be using this angle 30 degrees as well as that angle of 30 degrees. And let us try to concentrate on this circled part of the illustration. Kaya kung titignan natin siya, ibalik natin siya dito, ito yung ating point B, i-drawing natin muna yung part na ating pinutol yan, ito yung ating member AB. But I only consider the lower part. Yung AB natin ay humaba by this amount, and this amount is 0.12. While yung BC natin ay umikli naman ng this amount, and this amount is 0.072. So from the ends of the elongation, from this ends original length of B, ang angle natin tinutukoy dito is 30 degrees, while this one is also 30 degrees. Diba? Kaya kung titignan natin itong point nito mula sa D, okay, yung kanyang ends ng deformation ay lagyan natin ng point D at saka E dito, And from the point D, we draw a perpendicular line. Similarly, at the end of the deformation of member kay BC, which is at E, mag-drawing tayo ng perpendicular line. Ito ngayon makikita natin. Kaya yung B natin, ay mapupunta dito, ito yung ating final position of the B. At tawagin natin siyang B sub F, or the final position of B prime. And we are looking at what is the horizontal movement of this from this point up to that point. Diba? So, sa unang tingin, medyo mahirap siya. Pero gawin natin simple yung solution. And to make it simple, it's just a matter of creating a series of triangles. So, let's start drawing a horizontal line passing through BF. Passing through BF. Horizontal line, ano? And then we try to draw line, vertical line, passing to D. Dito naman tayo, no? Ito yon. Similarly, we also imagine that a vertical line be passed through A. Ito yung ating E. Yon. So after we have defined those vertical lines and horizontal lines, let us try to label the intersections of the reference lines that we have drawn. If we have selected our point E, then we select this as our point F, we treat this as our point G, and this as our point H, so that this becomes our point I. Diba? Now let us try to identify the property. Kung itong angle ay 30 degrees, how much will this angle be? So we would expect that this angle will also be 30 degrees. Ganoon din sa side ito, dahil itong angle na ito ay 30 degrees, itong angle na ito dapat ay 30 degrees din. Diba? Now, tingnan natin itong triangle na ito. Yung triangle ay right triangle. So that if this is 30 degrees, asahan natin itong angle na ito ay 60 degrees. At ganoon din sa kabilang side. Kung ito ay 30 degrees, dahil ito ay right triangle, itong side na ito, angle na ito pala, ay also 60 degrees. At lalabas, itong angle na ito, angle na ito, ay 60 degrees din. Diba? Now, gusto ko tingnan natin, if we're going to draw line from B to BF, to connect these 2 points, B to BF, by a straight line. Straight line tayo dyan. And we define that this angle, as beta. While this angle, i-define natin siya as theta. Therefore, we can say that from the triangle, from the figure, it will be noted that the sum of beta and theta will be equal to 60. Kaya pag pinakita natin yan, theta plus beta is equal to 60. So that, from here, makakaroon tayo ng relationship that beta is equal to 60 minus theta, or theta equals 60 minus beta. Diba? So, ang maganda dito, meron tayo dito ang series of adjacent triangles na nabuo. Do you see that this triangle DBBF ay adjacent to triangle BENBF? So, unahin muna natin yung triangle BDNBF. BDN, ito yun, itong triangle ito. Kulayan ko na nga naman, ayan. Diba? BDNBF. So, that is a right triangle. And from the right triangle, we can express the function of this right triangle in terms of the angle beta. Okay, so that sine of beta representing the ratio of the opposite to the hypotenuse, then this becomes 0.12 divided by this hypotenuse, and that is equal to BBF. So that in this relationship, we can solve that BBF is equal to 0.12 divided by sine of beta. Now, similarly, we can also say that we can also see from triangle BEBF, itong side naman, kabilang side naman, BEBF, itong triangle naman ito, di ba? And in the triangle, we can also express the function that sine of theta shall be the ratio of the opposite of 0.72 over BBF. And from here, BBF can be solved as the ratio of 0.072 divided by sine of theta. And because BBF is equal to BBF, therefore we can equate the two equations. So that 0.12 is to sine of beta shall be equal to 0.072 is to sine of angle theta. But we just have expressed that beta is equal to 60 minus theta. So if we will be substituting it here, therefore our equation will be 0.12 is to sine of 60 minus theta shall be equal to 0.72 k over sine of theta. So, ito palang equation na ito, kung ikaw ay may highly technical na calculator, pwede mo na siyang masolve. You can already solve for the angle theta. Pero kung hindi mo gamit or wala kang dalang ganang klase ng calculator, pwede pa siyang expand tuloy-tuloy na by applying the function of the sum of difference of two angles, that is sine of 60 minus theta, di ba? So this will be simplified. I will have here, okay, taking the ratio, ilipat ko lang, cross multiply ko lang, that is 0.12 over 0.072 shall be equal to sine of 60 minus theta over sine of theta. And that if we will be expanding this, sine of 60 minus theta into the following, that is equivalent to sine of 60 cosine of theta minus cosine of theta sine of cosine of 60 sine of theta over k sine of theta. So from here you can already simplify because you already have one k angle expression in terms of theta, and you can express the sine of 60 as well as the cosine of 60. So that if this will be simplified, I have 0.12 divided by 0.072 shall be equal to sine of 60 cosine of theta minus cosine of 60 sine of theta. Kinopya ko lang muna siya para makita natin, ano? Okay, therefore, we will be simplifying this actually equal to, okay, 5 over 3. Ano? Yung ratio na yan is actually equal to 5 over 3. So that this will be equal to, okay, sine of theta, okay, multiplied by cosine over sine. And that is sine over cosine is tangent theta. At itong kabilaan naman, pag sinimplify mo itong kabilaan naman ito, kaya anong nangyari dyan? It is just actually equal to cosine of 60, and cosine of 60 is 0.5. And so from here, you can now solve for tangent of theta, which is equal to 0.33974. Or if you may want, you can still solve for the angle. That angle equals 21.78679 degrees. Now, after you have taken for the angle theta or the function of the tangent of that theta, so you can go back. You can go back to the same triangle, okay, by solving the line EBF, itong line ito from this point up to that point, di ba? Using the same triangle, that the ratio of, okay, tangent theta is the ratio of the opposite to the adjacent side, and that's equal to 0.072, okay, divided by the line BF, okay, to A. And so, because tangent theta is already computed to be 0.399704, therefore you can solve for BFE, or this line actually, to be 180,133 inch, o inch. Ano? So, nasolve natin ito. Now, after we have solved for that, okay, let us now consider the triangles BIE. Okay, saan yung triangle to? Ito, BIE, and triangle EFBF. EFBF, ito yun. Kulayan ko siguro mas maganda, no? Kulayan natin ito yung triangle nito ko. Okay? Now, from that triangle, makikita natin yung ating hinahanap because we are going to observe the triangle. Okay? The vertical component of the movement of P from this point up to that point ay actually the sum of what? IE and EF. Yun, IE and EF. While the horizontal component of the movement of B, ito daw, galaw nito mula dito hanggang ganyan, is the difference between BF to F and BI. Yun, is the difference between BF to F and BI. Now, so that if we are going to solve for, okay, the component, horizontal component of the movement of B, and that is BF, B horizontal. And in the figure, it is this difference, ano? BF to F minus BI, this one. And that will be equal to, okay, this distance multiplied by the cosine of 60, okay, minus 0.072 cosine of k30. So that if this will be substituted and simplified, you can solve for the horizontal component to be 0.027713. Similarly, if you are to solve for the vertical component of that movement of B, you will expect that it is the sum of IE and EF. And so this is how we show okay, the application of the axial deformation in dealing with engineering problems. I hope that you're able to follow the concept, particularly on the step-by-step procedure in solving that problem. Again, thank you guys for watching.